The next two sections we cover together, sections 2, 3, and 2, 4, because they refer to linear functions, and students are usually a lot more familiar with linear functions. You've already worked in the past to graph lines, to calculate slope, to figure out what those y-intercepts are. So we're going to go ahead and cover both of those sections together today. Slope refers to the constant rate of change in a linear function. In the last video, we talked about our difference quotient, which calculated the average rate of change between any 2 points on a curve, because a curve does not have a constant slope or a constant rate of change. My question I ask here, how do I know if I have a linear function? Because I only have a slope if I have that linear function. Well, I have a linear function if I have a graph that is a straight line. My graph is a straight line. Or if I have the equation, that equation is first degree. So I just have x, not x squared or square root of x or anything along those lines. Here we have four coordinate planes, our little xy coordinate planes, and we're going to graph our four possibilities for slope. First of all, as I move from left to right along my x-axis, if my y value, my function value, is increasing, then my slope of my line is positive. So if as I move from left to right, my function is increasing, I have a positive slope. However, if as I move from left to right, my function is decreasing, I have a negative slope. What about if as I move from left to right, my function is flat? Well, we say that that is a constant function, and we say that the slope is 0. Now, it's a different thing to say a slope of 0 versus no slope. My vertical line here is what we call no slope, and this line is not a function. Think about your vertical line test to see whether or not your graph is the graph of a function. This is the vertical line, so it is not a function. It has no slope. Now, it can be difficult differentiating between a slope of 0 and no slope. Here's how I do it. I used to, when I taught junior high, I would tell my students I'd make a big story out of this, and I'd talk about going skiing and wearing a purple fuzzy suit with a little pom-pom hat and all this stuff. But basically, if you are skiing and you are skiing flat, well, that's fine, right? You can do that. We have 0 slope. We're not going down the mountain. The slope is 0, but I can ski that. It's a little bit of work, but it's doable. However, if I get on the lift and I'm not paying attention and I miss my stop and I end up getting off at the very tippy top of the mountain, I turn around the wrong way because I get flustered because I didn't mean to go up to the very top of the mountain, and I end up where I shouldn't. And I look down, and when I look down, it is just down. Well, that is no slope. If I try that, I'm going to die. You can't ski no slope. That is just drop. So that maybe will help you keep straight the difference between 0 slope and no slope. If it's no slope, it's not a function. If it's a 0 slope, it's a constant function. Okay, how do we find a slope? Well, finding slope, our variable that represents slope is m, and I'm really not sure why. I've never gone and looked that up. But slope, as we mentioned in the last video, is change in y, the difference in the y coordinates, over change in x, the difference in the x coordinates. Another way to talk about slope is the formal definition, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. This sometimes we can get hung up worrying about what's my y sub 2, what's my y sub 1. So I tend to stay away from that one. I think about slope as either rise over run, because my y-axis is my up and down or my rise. My x-axis is my left to right or my run. You can also, my shorthand that I like to use for the formula for slope is delta y over delta x. Change in y over change in x. The triangle is a Greek delta, and it means change. So delta y over delta x means I'm doing the change in y over the change in x, which reminds me, rise over run. Now that's important because it doesn't matter which x and y you start with. What matters is that when you're calculating slope, you pick a point to start with and you stick with it. So if I want to find the slope for this line on number 1 that contains these 2 points, if I put these 2 points on a graph, connect them with a line, what will be the slope of that line? Well, slope is change in y over change in x. My M for slope, change in y over change in x. I can start with either y coordinate. Let's say we start with 3. So then my y coordinates would be, my numerator would be 3 minus 4. And my denominator, my x coordinates, the change in x, since I started with this y coordinate, I start with its x coordinate. I have 2 minus, and then the other x coordinate is 6. So that gives me 3 minus 4 is a negative 1. 2 minus 6 is a negative 4. A negative divided by a negative is a positive. So my slope is a positive 1/4. Now, I emphasized that it didn't matter which ordered pair I start with. Let's do this one problem using the other ordered pair first to see what happens. Change in y. So I pick the other y coordinate. That makes my numerator 4 minus 3 instead of 3 minus 4. When I start with this y coordinate, I also have to start with this x coordinate, which makes my denominator 6 minus 2 instead of 2 minus 6. This time when I do the subtraction, I have 4 minus 3 is a positive 1 and 6 minus 2 is a positive 4. So it truly does not make any difference which point I start with. I'm going to get the same slope as long as I work the problem correctly. Okay, let's do this second example. We're going to find the slope of the line that would contain these 2 points. Slope is m. Change in y over change in x, and it does not matter which y coordinate I start with. I'm going to choose to start with this negative one just for fun. So that would be negative 4 minus 3, because that's my other y coordinate. And then, since I started with negative 4, in my denominator I start with 6 minus, well, the other x coordinate is negative 2. So I have negative 4 minus 3. A negative minus the negative, those are both negative. So I think about adding the opposite, that gives me a negative 7. In my denominator, if I think about adding the opposite, that becomes plus a positive. 6 plus 2 is 8. My slope is a negative 7/8. If you choose to check it and start with the other ordered pair, you're going to get the same result. And then finally, the slope between these 2 points, a line that contains these 2 points, we are going to find our slope, change in y over change in x. This time I will start with the first y coordinate, negative 1 minus 4, because that's my other y coordinate. And then my denominator would be negative 3 minus a negative 2. So I'm always subtracting, and I deal with the negative coordinates as necessary. A negative 1 minus 4 is negative 5. A negative 3 minus a negative 2, I think about adding the opposite. That becomes negative 3 plus 2, which is negative 1. A negative divided by a negative is positive. And anything with a denominator is 1 is an integer. So my slope is a positive 5. That's going to be a very steep positive slope. This is, number 1 is still a positive slope, but it's not very steep. It's fairly flat. Number 2 is a negative slope. All right, just a little bit of a reminder, and well, no, we didn't talk about general form of a linear equation. We had talked about general form of a quadratic equation. We have 3 basic forms of our linear equation: general, point slope, and slope intercept. You start with the one that has the information you're given, and you're usually moving toward the slope-intercept form because it's the one that is the most user-friendly for us. We can graph directly from the slope-intercept form without any extra work. My general form is set equal to 0. So it would be ax plus by plus c equals 0, where a, b, and c are real numbers. My point slope form is y minus y sub 1 equals m, where m is my slope, times the quantity x minus x sub 1. And then I need to know for this equation, for this form of the equation, I need to know the slope, and I need a single point on the line. I need to be given a point on the line, x sub 1, y sub 1, so that I fill in for those coordinates. So I'm filling in a value for slope, I'm filling in the coordinates for any point on the line. I leave this y as y, and I leave this x as x. And again, excuse me, that's my lotion getting knocked over. Again, we are usually working towards our point slope, or excuse me, our slope-intercept form of our equation. Y equals mx plus b, where my equation is solved for y. When my equation is in this form and it's solved for y, the slope is the coordinate of the x. So there's my slope of my line. And this constant b is my y-intercept. Y-intercept. The y-intercept happens when x is 0. And if x was 0 here, you see that y is equal to b. So it's my y-intercept. All right, let's look at the next page. Always remember, you are free to fill things in, pause the video, rewind the video. Don't let my pace dictate your pace. We're going to do a couple of these practice problems, and then I will give you the answer to the third. I'll encourage you to pause the video and work it on your own. Using the examples from the last page, first find the point slope form of each equation, then find the slope-intercept form, and finally we're going to graph. The examples from the last page. Well, number 1, right here, I have the points 2, 3, 6, 4. Those are points on my line. And I know I have a slope of 1/4. So we can choose either one of these points to use. Let's choose this point, 6, 4, and then we're going to use our slope as 1/4. And we are going to graph that line. So we have the point 6, 4 that we know is on the line, and we have a slope value of 1/4. We're told to start with the slope-intercept form. Sorry, I'm confusing my terms today. We're told to start with the point slope form of the line. So we start with y minus y sub 1 equals m times the quantity x minus x sub 1. We are not changing the y, and we are not changing that x. So we need to fill in our slope. Our slope is 1/4, and we need to fill in the coordinates for that point, where we have x minus 6, because that's the x coordinate, and y minus 4, because that's the y coordinate. Now this would work just as well as with the other point had we chosen it. That doesn't make any difference. Okay, so I need to distribute first because order of operations. I have y minus 4 equals 1/4 x minus, and then 6 times 1/4, I'm going to do a little side work here. 6 times 1/4, 6 over 1 times 1/4 is 6/4. That is not in lowest terms. Those are both even, and that is reducible to 3/2. So I'm going to leave it as 3/2 there. Now I need to move this 4 to the other side. So I need to add 4 to both sides of my equation. I add the opposites here, that adds to 0, and I've solved for y. I'm getting it solved for y. This is my slope-intercept form, so my x term is 1/4 x. I need to combine these constants. To do that, to add or subtract fractions, I need a common denominator. 4 is the same as 4 over 1. I need it to have a common denominator with 3/2. So I need a denominator of 2. If I change my denominator to 2, 1 times 2 gives me 2. I have to also multiply my numerator times 2. So 4 over 1 is the same thing as 8 over 2. So what I have here is -3/2 and +8/2. -3/2 plus 8/2 gives me a +5/2. This is my slope-intercept form of the equation because it is solved for y. I already knew that my slope was 1/4. Now I know that my y-intercept, if x is 0, y is 5/2. Well, what does 5/2 look like on my graph? 5/2 is the same thing as 2 1/2. So if I graph this line, I'm going to start at my y-intercept. I'm going to say, okay, 1, 2, 2 1/2 would be right here. And then I'm going to apply my slope. My slope is rise over run. It's positive, so I'm going to move up and to the right. Or potentially, I could also move down and to the left, and that's still going to give me positive slope. Let's go up and to the right. So I'm going to go up 1, right 4. So up 1 puts me here at 3 1/2. To the right 4 takes me to 1, 2, 3, 4, and that is another point on my line. Or I could go, like I said, down 1 and to the left 4, 1, 2, 3, 4. There's another point on my line. Grab a straight edge because I am not very good at connecting points with a straight line freehand. There's my line with a positive 1/4 as slope. All right, let's go ahead and do number 2 together. And then I'm going to let you do number 3 on your own, and I will give you the result to check. So just like this last one, we're starting with our point slope form and working toward our slope intercept form. This is my point slope form that I started with here. Okay, right there. And then I ended up in my slope intercept form. So number 2, on the last page, number 2, we had these 2 points and a slope of -7/8. I can pick either point. I picked the second point here. Let's pick the first point there and use -2, 3 as the point. So we know that our line goes through the point -2, 3, and we found that it has a slope of -7/8. Okay, so we're going to fill into our point slope form of the equation. We're going to fill in and we're going to say, all right, we have y minus, well, y sub 1 is 3, equals our slope, -7/8, times x minus, and then x sub 1 is -2. Well, that's just the same thing as x plus 2. So I have y minus 3 equals -7/8 times x plus 2. That's my point slope form. Watch my math lab homework. It will sometimes ask you for that point slope form. This is what it's asking for. I need to turn that into my slope intercept form by solving for y. First step is to distribute the slope. So I have on the right -7/8x minus, because a negative times a positive is a negative. 7 times 2 is 14 over 8. Well, 14 and 8 are both even, so that reduces to 7/4. Now I need to finish solving for y by moving that 3 over. When I add 3 to the other side, I have to end up with a common denominator so I can add my fractions, add and subtract my fractions. So my y is equal to -7/8, sorry. And I need a common denominator here. Well, that common denominator is going to be 4. 1 times 4 is 4. 3 times 4 is 12. So I have -7/4 plus 12/4. A -7 and a positive 12 is a positive 5/4. And this is my slope-intercept form of my line, where I have a slope of -7/8. Notice that the slope is the coefficient of the x term when I'm in this form of the equation. And my y-intercept, when x is 0, y is 5/4. Well, 5/4 is 1 1/4, so it's just over 1. Going to be right there. My slope tells me I'm going to be going down 7 to the right 8. So my little graph, that's not going to fit very well. We're going to freehand that the best we can. So if I go down 7, I'm going to go down 1, 2, 3, 4, 5, 6, 7, about to right here. And then I need to go over 8. So that would be 1, 2, 3, 4, and then that far again would get me to the 8. So 5, 6, 7, 8. About right there should be down 7 to the right 8 from my intercept. And here is a graph of my line. On my math lab, you're not going to have to guesstimate that location of that other point. You'll be able to pick it out on the graph correctly. Okay, we have one more example. I want you to look back at number 3. This is what we were given on number 3. I want you to go ahead and use this second point and your slope of 5. Put that in the slope in the point slope form, and then find slope-intercept form, and then graph while your video is paused. So pause your video, do those things, and then come back and check. All right. This is what you should have ended up with. When you use your point slope form of the equation, with this point, this is what that looks like. If you had chosen your other point, this point slope form would have looked different according to the other point. Your slope-intercept point is going to be the slope-intercept form will be the same, however, because you will have the same slope and the same y-intercept. Now, because our y-intercept is 0, 14, I decided I needed to count by 4 on my axes. So I numbered my x and y axes accordingly. I placed my intercept at 0, 14, and then I thought, okay, I need to go down 5 over 1, down 5 again over 1, and that puts me right here at the point -2, 4. And I connected those points to get my line with a very steep positive slope of 5. Now that's all of the information on 2-3. Let's go ahead and look at 2-4. 2-4 continues talking about linear functions. The title of 2-4 is very basically more on slope. We're going to talk about the difference between parallel and perpendicular lines. Now, if I have two lines on the same plane, I only have two options. They're either going to be parallel and never intersect, or they're going to cross somewhere, and we say that those two lines are intersecting lines. If they cross in such a way that they form a right angle, then they are perpendicular to each other. So by definition, parallel lines are 2 points in the same plane that never cross. They never cross because they have the same slope. They are slanted to the same degree. Although they have the same slope, I see that they have different y-intercepts. Because they have the same slope, they will never intersect. When I look at the two lines that I'm given, I see that I'm told that this line is y equals 2x. This line L is parallel to that line. It would be y equals 2x, y equals 2x, and then the y-intercept is down here at -6. So y equals 2x minus 6. This would be 2x plus 0. It goes through the origin. This would be 2x minus 6. It still has the slope of positive 2. The slope of this line is 2, and the slope of this line is also 2. They have the same slope. Let's look at this example of perpendicular lines. When I have two lines that intersect in such a way that they form right angles, that happens because their slopes are opposite and reciprocals of each other. When I multiply together two terms that are opposite and reciprocal, the result, the product, is -1. So let's think about this. This first line is this first line over here. This is just y equals 2x. The slope is a +2. This line, however, has a slope of a -1/2. It no longer has the same y-intercept. This line, in this case line L, I know that it is perpendicular to the original line, so it has a slope that is opposite and reciprocal, so it would be y equals a -1/2 x. And I can see that the y-intercept is here about 5. We're going to go ahead and say +5 as my y-intercept to get the equation for that line. We're told that they are perpendicular and shown that on the graph because of the right angle. 2 and -1/2 are opposite and reciprocals of each other. If I multiply together 2 times -1/2, I get -2/2, which is the same thing as -1. That is going to happen every time I multiply together the slopes of lines that are opposite reciprocals. Okay, we have a couple of examples here that we're going to do together. And then there are 3 practice problems on that last page that we are not going to do together today. Our first example says to find the slope-intercept form of the equation of a line that goes through the point -8, -10, and is parallel to this given line. So we know a point and we know the slope. Because if we know our line is going to be parallel to this line, we know that the slope of our line will also be -4. Let's start with the point slope form. We need to get to the slope-intercept form. So when I start with my point slope form, y minus y sub 1 equals m times x minus x sub 1. I plug in the values, the x and y coordinates for the given point, and I plug in the slope. That gives me y minus, well, this y is -10, so y minus a -10 is the same thing as y plus 10, equals my slope of -4, because those two lines are parallel, x minus a -8. And x minus a -8 is the same thing as x plus 8. So I have y plus 10 equals -4 times x plus 8. That's my point slope form. I need to solve for y to turn it into slope-intercept form. To do that, my first step is going to be to distribute that slope. That gives me y plus 10 equals -4x minus 32, because -4 times 8 is a -32. Now I'm out of space down here, so I'm going to adjust, and I'm going to move up here. Y plus 10 equals -4x minus 32. To finish solving for y, I need to move that 10 over by subtracting it. That gives me y equals -4x minus 42. This is my equation of a line that is going to be parallel to this given line and go through this point. The slope of this line is -4. Notice, same slope. The y-intercept of this line is 0, -42. Whereas the y-intercept of the line I was given to look at the slope on was a +5. So these two lines are parallel. They have the same slope, different y-intercepts. Now, the next example says to find the slope-intercept form of the equation of a line that goes through this point again, but this time it's perpendicular to that given line. So we're using the same point, same line, but the slope of the line I'm interested in is not going to be -4. This time, since it's perpendicular to that line, the slope of the line I'm interested in is going to be the opposite, so it will be positive, and it will be the reciprocal. The reciprocal of 4 is 1/4. So that's the slope of the line I'm interested in. point slope form first. Y minus y sub 1, it becomes y plus 10, equals, this time my slope is a positive 1/4, and then over here I have x plus 8 again. This is the point slope form, that's my starting place. I need to turn it into the slope-intercept form. First I distribute my slope, y plus 10 equals 1/4 x plus 1/4 times 8 is 8/4, which is just 2. And then I subtract 10 to solve for y. I end up with y equals 1/4 x minus 8. That's the slope-intercept form of the line that I'm interested in. Note that the slope of this line is a positive 1/4, and the y-intercept of this line, when x is 0, my intercept is negative 8. The slopes of these two lines are opposite reciprocals. They don't have the same y-intercept. They could have the same y-intercept if they happen to intersect each other at the y-axis. All right, I know there are 3 practice problems available. We're not going to go through those right now in this video.